Good morning students. In the last class we solved few problems under Newton's method of interpolation, and we have seen the problems where x values are not given in classes. Separate values of x were given, but here in this class we will solve one problem where values of x are in classes. So class intervals are given, then how to interpolate the values? See here, interpolate the number of person below the age 70 years from the following data, and the data given is age in years as well as number of persons. Age 0 to 20, 20 to 40, 40 to 60, 60 to 80 and 80 to 100. Whereas number of persons 333, 160, 135, 67 and 60. Now they have asked to interpolate the number of persons below the age 70 years. See, 70 is not one of the class limits of x data. See, in x class limits, in the class limits 70 is not there. That's why we can't apply binomial expansion method. We have to apply Newton's advancing difference method. So write down in the solution, since the value to be estimated, the value to be estimated is not in the class limits, of the data that is x. Apply Newton's method to estimate the number of persons below the age 70 years. Below the age 70 years. So we are going to apply Newton's advancing difference method to find out the number of persons below age 70 years. So here class intervals are given. So what we have to do is, this class intervals we have to this frequency distribution we have to convert it into less than cumulative frequency distribution. Whatever frequency distribution is there, that we have to convert into it is age in years. X is age in years. First column leading difference table, first column will be age in years. That is, we can denote it as X. Next column is Y. That is number of persons. Number of persons. We can denote it as Y. Next column will be leading differences. Leading differences. So in leading differences, as we know, 5 values. The known values of Y is 5. We are going to find out up to delta raised to 4. First one is delta raised to 1, delta raised to 2, second difference, third difference and fourth difference. Fourth leading difference. So these are the columns. Now we will insert the values in this table. First, age in years. 0 to 20. We are going to convert it into less than frequency. So 0 to 20 we can write it as below 20. Below 20. Next, 20 to 40 we can write it as below 40. So leave one line. Next, below 40. Next, 40 to 60 it will be below 60. 60 to 80 we can write it as below 80. Next, lastly, below 100. 80 to 100 we can write it as below 100. Now we will write the number of persons. So here 0 to 20 there are 333 persons. So below 20 we can write it as 333. So this is Y0. Next, 20 to 40, in the age group 20 to 40 there are 160 people. But here we are going to write it as below 40. Below 40 means it includes 0 to 20 as well as 20 to 40. Below 40 means it includes from 0 to 40. That's why we are going to add number of persons of both the classes. 333 plus 160. This is called as less than cumulative frequency. How to? Cumulative frequency is nothing but added up frequency. So less than cumulative frequency means we are going to add the frequencies which are below that. So 333 plus 160, it is 493. 493. You can mark it as Y1. Next, below 60. Below 60 means it includes all these three values, 0 to 60. So add all the three values. 333 plus 160 plus 135. It is 628. So this we can denote it as Y2. Next, below 80. Below 80 means from 0 to 80 we are going to add the frequencies. 333 plus 160 plus 135 plus 67. It will be 695. That is Y. Lastly, below 100 means from the beginning till 100 years. How many people are there totally? That we are going to calculate by adding all these values. 333 plus 160 plus 135 plus 67 plus 65. It is 760. This we can denote it as Y4. So like this, we have converted the given frequency table into less than cumulative frequency table. Now easily we can find out the leading differences. So first order leading difference, Y1 minus Y0, that is 493 minus 333. It comes to 160. In this middle space we are going to write it 160. Delta 0 raised to 1. Next, 628 minus 493. It is 135. Delta 1 raised to 1. Next, 695 minus 628. It is 67. Delta 2 raised to 1. Next, 760 minus 695. It is 65. Delta 3 raised to 1. Next, second leading difference. 135 minus 160. It will be minus 135. See here, 135 minus 160. So greater number sign is minus. So when you deduct it, it will be 25. That is delta 0 raised to 2. Next, 135. So 135 is greater. So greater number sign we are going to apply it as minus. Now deduct it. When you deduct, the answer will be 68. Delta 1 raised to 2. Next 65 minus 67. 65 minus 67. Greater number sign is minus. See, when you deduct it, it will be 2. 67 minus 65 is 2. Minus 2. Delta 2 raised to. Next third leading difference. Delta 1 raised to 2 minus delta 0 raised to 2. That is minus 68 minus 68 minus 25. Minus 25. So minus 68 minus into minus it will be plus 25. So greater number sign is minus, and when you deduct it, it will be 43. So here we are going to write it as minus 43. Delta 0 raised to 3. Next minus 2 minus 68. Minus 68. So minus 2 minus 68. Minus 2 minus into minus it will be plus 68. Greater number sign is plus. So value whatever you are going to write, it will be of positive. Next minus into plus minus. We are going to deduct 68 minus 2. It will be 66. Delta 1 raised to 3. Next calculation we are going to show it in the fourth leading difference column. These two values we are going to deduct. That is 66 minus 43. 66 minus 43. So 66 minus into minus it will be plus 43. When you add, it will be 109. That is delta 0 raised to 4. Like this we have to calculate the leading difference table. This is delta raised to 4. Delta raised to 1. Second leading difference, third leading difference, and this is fourth leading difference. So in fourth leading difference it will be 109. Delta 0 raised to 4. Now we will apply the formula. Before that, we have to calculate the value of x, because in the formula we need the value of x. So first of all we will write the formula of x. X is equal to value of x to be interpolated minus value of x at the origin divided by difference between two adjoining values of x. Two adjoining values of x. So first of all, value of x to be interpolated. Here we are going to interpolate the value of x is equal to 70. Therefore value of x to be interpolated is 70. Next, value of x at the origin, that is beginning value of x in the table, it is 20. So 70 minus 20 divided by difference between two adjoining values of x. What is the difference between two adjoining values of x? 40 minus 20 is 20. Next 60 minus 40 is 20. So difference is 20, which is equal to 70 minus 20, it will be 50 divided by 20 is equal to 2.5. So x value is 2.5. Next, we need the value of x minus 1, x minus 2 and x minus 3. So x minus 1, x value is 2.5 minus 1, it will be 1.5. Next, x minus 2, 2.5 minus 2 is equal to 0.5. Next, x minus 3, 2.5 minus 3 is equal to minus 0.5. Now, apply the formula of yx. So yx formula is, you know that x is equal to 2.5. Now, y formula is yx is equal to y0 plus x delta 0 raised to 1 plus x into x minus 1 divided by 2 factorial 0 raised to 2 plus 0 raised to 2. Delta 0 raised to 2 value is minus 25. Next plus x value is 2.5 into x minus 1 is 1.5. Next x minus 2 value is 0.5 divided by 3 factorial. 3 factorial is 3 into 2 into 1. 3 2s are 6 into 0 raised to 3. What is the value of 0 raised to 3? Delta 0 raised to 3 is minus 43. Minus 43 plus x value is 2.5 into x minus 1 is 1.5. X minus 2 is 0.5 and x minus 3 is minus 0.5. Minus 0.5 divided by 4 factorial. 4 factorial means 4 into 3 into 2 into 1. 4 3s are 12, 12 2s are 24. 0 raised to 4. What is the value of 0 raised to 4 in the table? It is 109 into 109. Now we can simplify it. Now simplify this equation. 333 plus 2.5 into 160. 2.5 into 160. Answer is 400. Next plus into minus, it will be minus. 2.5 into 1.5 into 25 divided by 2. It is 46.875. Next plus into minus, it will be again minus 2.5 into 1.5 into 0.5 into 43 divided by 6. Answer comes to 13.4375. Next plus into minus, it is minus 2.5 into 1.5 into 0.5 again into 0.5 into 109 divided by 24. It is 4.2578. Now solve this. 333 plus 400, it is 733 minus 46.875 minus 13.4375 minus 4.2578. Answer comes to, that is y70 is equal to 668.4297. So you can write it as the number of persons below the age 70 years is, therefore number of persons below the age 70 years is, we can round it off 0.4. It is not greater than 5, so we can write it as 668. So there are 668 people who are below the age 70 years. So this is how you are going to solve the problem when class intervals are given. On the basis of the question asked, you are going to convert the given frequency table into cumulative frequency table. If below is asked, then less than cumulative frequency. If above is asked, then you are going to consider the more than cumulative frequency table, and on the basis of that you are going to solve this problem. So this is how you are going to solve different types of problem under Newton's advancing difference method. So here your fourth chapter gets ended. Now in the next class, in our upcoming class, we are going to start with the next chapter, that is index number. In upcoming class we will start with index number chapter.